Good afternoon and welcome to Hand-Wavy Chemistry, where we do not delight in the details, but rather bask in the big picture. Today, it's problem time, where we answer chemistry-related questions, either from old exams, or popular web searches, or even viewer-submitted questions from down in the comments. Today, we are looking at 3 questions, all of which come from past AP chemistry exams. The College Board very kindly publishes the short answer sections of their exams on their website. They also include marking guides and their own comments, and I will include links to these resources in the video description. Now, the 3 questions we're going to look at today all relate to photoelectron spectroscopy, which is a way to measure the binding energy of electrons in a substance. Now, when we look at these spectra, there are 2 main things we want to pay attention to. One is the energy associated with the electrons, and the other is the relative number of electrons, so the heights of the different peaks. Now let's jump in and look at the first question. Our first question comes from the 2018 AP Chemistry Free Response section. It's question number 7, and it says, the complete photoelectron spectrum for an element is represented above, and we are asked to identify the element. The colorful outline of a periodic table was not part of the question, but I've added it because it will help me to explain my thought process as I go through and answer this question. Now, the first thing you might notice is that for our x-axis, we have a 45 at this end and a 0 at this end. This feels backwards. We are usually told that we go from smaller to larger as we head across an axis. However, each of the peaks that you see represents some number of electrons, and this end of the axis is closest to the nucleus. So you can also think of it as at the end, where the 45 is our nucleus, and as we move out, we get different electrons. Because the nucleus is positively charged and electrons are negatively charged, those electrons that are closest to the nucleus are more tightly held than those that are further out. The periodic table is arranged in such a way that we can look at it and think about where an atom's electrons are. As we move from a different color to another color, so for example, if we were to go from here, this red section, over to this yellow section, we would see a small change in the distance from the nucleus. So it would be slightly easier to remove those electrons. As we go down a row, that is a significant jump. So we'd expect to see a large gap between those electrons, the energy that they are held with. So if we look up here, we can see that there is a height of 2 on this, 2 on this, and 3 on this. So just starting at the top of our periodic table, we can say, well, there's 1 red one, 2 red ones. Those are the closest. So that's going to be this first peak here. Then we can have, here's 1 red one, a second red one. That's going to be the next peak. And then for the final peak, there are 3 electrons. We go 1, 2, 3. So whatever element is here, that is going to be the answer to our question. And in this case, it just so happens to be nitrogen. Our second question comes from the 2019 AP Chemistry Free Response section. And we're just going to look at question 5, part A, subsection 2, trying to identify the element that is shown in the complete photoelectron spectrum that is represented. They haven't labeled the axes, but looking at it, you'll notice that once again, the largest values are on the left and the smallest are on the right. This is because the peaks representing electrons on the left are those that are closer to the nucleus, and those on the right are further away. so are less tightly held. The heights of the peaks, once again, those represent how many electrons there are. And we will see large jumps when we move down a row of the periodic table, and small jumps when we move from one colored section to another colored section. So the first row of the periodic table can hold 2 electrons. So this will be a 2. Looking at this, you can see it's 1, 2, 3, 4. This must be 6, 2, 6, 2. Coming now down to our periodic table. 1, 2. We should now expect a large jump, which is what we see. And we go 1, 2, followed by a small jump. 1, 2, 3, 4, 5, 6. That completes that row of the periodic table. So it's now time for a large jump, which is what we see. 1, 2, small jump. 1, 2, 3, 4, 5, 6. Big jump. 1, 2. And at this point, there are no more peaks, so this is the element that we have been asked to identify. Looking at a labeled periodic table, we can see that it is calcium. So the answer here is calcium. Our final question comes from the 2021 AP Chemistry exam. And it's asking us to do something a little bit different. In the previous 2 questions, we were given a complete spectrum and asked to identify the element. This time, we've been given an incomplete spectrum, and we've been told which element it is, and they're asking us to put in the missing peak. The exam specifies that the peak is for the 3p sublevel. We don't have to worry about that. All we have to know is that there is a missing peak, and we need to add it. To do this, the first thing we need to do is identify where silicon is on a periodic table. If we look at a labeled version, we would see that it is right here. Now, we just do what we did before, matching up peaks to locations on the periodic table until we find how many we are missing. So, looking at these peaks, we can see if we go a height of 2, a 2, a 6, and a 2, 1, 2, 1, 2, 1, 2, 3, 4, 5, 6, 1, 2. We've now run out of peaks. So whatever we have here in this yellow section, that's where our missing peak will be. And we see we need 1, 2. So we need to add in another peak, a small jump to the right of the last one, with a height of 2. And that would be the answer to the question. Whenever you approach a question related to photoelectron spectroscopy, keep in mind the relative heights of the peaks show the relative number of electrons. And lower binding energies represent peaks that are further from the nucleus, and we usually draw them to the right in our spectra. Thank you very much for watching this video. If you've enjoyed it, please make sure to like and subscribe so you know when future videos are released. And if you have a question you'd like to see covered in a future problem time, please put it down in the comment section below. Thank you, and I hope you enjoy the rest of your day.